Yeah. I'm going to call on tables. I'm not going to let you just sit and slide down and slump down in your chairs today. So we're just going to start. I'm going to start with table number 7. Oh wait, there's nobody at table number 7. Darn it. Table number 8. Nope, that doesn't work either. Darn it. Because I'm failing. I don't know, table 11. I need to write this down so I've got it figured out. What's one thing you know at table 11, friends?
Mass is 50 kilograms.
Awesome. Where is that going to go in this whole scheme of things?
Givens.
In the givens, the mass is 50 kilograms. How many other people had that written down? Good for you. If you didn't, that's okay. We're all learning together. We're just kind of looking at it as like the first thing that's written there, right? So that's super helpful, right? 50 kilogram box. All right. I'm not going to call on tables, so I have all my numbers ready. So I want somebody from that table back there because I don't know your numbers. What else was something that you guys knew?
Applied force is 250 newtons.
The applied force is 250 newtons. Okay. So FA is 250 newtons. Cool. And in what direction is that applied force acting? X direction, do you guys agree? Yeah? I see a couple of heads going the other way. Haley, what are you saying? 30 degrees. And this one's a little bit confusing, so that's part of the reason I wanted to ask this question now. The 30 degrees, what does that mean? Generally, friends, if it doesn't specify otherwise, it's 30 degrees relative to the horizontal. And since Natalie pointed out a force, maybe we can put that force on the free body diagram. Does that seem like a reasonable choice? Yeah. Where would I draw that force? Any idea? It's going to be an arrow. And it tells me the direction right here, right? 30 degrees relative to the horizontal. I'm thinking it's going to be pulled up because it says he's applying a force. Yeah, I'm thinking that's what's going on here. So it doesn't matter to the left or to the right. So I'm going to ask, Max, do you want to go to the left or the right? To the right. Okay. So we're going to add that force. So let's add a force. Oops. Come on. A force like this. I'm going to go ahead and mark that as a 30-degree angle. We've started thinking about this before, friends. In fact, we started thinking about this before the trimester 1 ended. What do we label that force? Force of something on something. Maybe let's identify what our object is. What is our object? What's the object that's being, the forces are applied to? The box. On my next set of sheets that I made for you, I wrote this down. I put object, : You might want to write that down just because it's a good habit to kind of think about. So each of these forces is going to be something on box. Who's acting on the box at 30 degrees? What? A man. Yes, it's true. The force of the man on the box. What kind of force is that? That's our applied force. Okay? So again, if you don't have that drawn, go ahead and do it right now. Don't be afraid to try. The only way that you learn is to try. Okay? All right. I need something else. Instead of calling numbers, I'm just going to go around the room. So Olivia, your table is next. It doesn't have to be you, but somebody from that back table. Can you tell me something else that you can fill in on the left-hand side of the chart?
It has a constant speed, so there's no acceleration.
Love it. Does that make sense? It's a constant speed, so there's no acceleration. I'm going to write that down on my givens because that's awesome. The acceleration is equal to 0. And I'm just going to underline where we know that because it does say that right there. That was kind of a hidden given. Nice work. Nice work. Max, I put you on the spot already. I'm going to come over here. What's another thing that you know, my friends?
One of our unknowns is the frictional force.
Absolutely it is. One of the unknowns is the frictional force. FF is equal to question mark. Awesome. All right. Making our way around. Connor, it's your table. What's something you guys know? And it doesn't have to be a given or an unknown. It can also be a force that's acting on the box. You don't know the value of the normal force. That's true. So we could put that, because that asks us to figure that out, doesn't it? So we can put that down here in the unknowns. And actually, I should have done this before. We can actually, because those are both forces. If they're forces, then we've got to put them in our free body diagram. So let me ask, I'm going to ask my table right over here. Whoever wants to talk. Which way is the normal force going to be pulling or pushing? Up, straight up. What does the word normal mean? Say it loud. Perpendicular, it does. And this is on a surface. The surface happens to be, I'm just going to draw that surface because it's kind of helpful for me to see. Okay, this is my surface. The normal force is always going to be perpendicular to that surface. So let's go ahead and draw that force. It's going to be up in this direction. And how do I label that? That's the force of the, what is acting on the box? What's that? The surface? Do we know what the surface is in this case? The floor? Yeah. And then in parentheses, we're going to say FN. How are we doing? Is that okay? Okay. I know it's been a little while since we've gone through all of this process, but I do want to remind you that this part and writing out the F-net equations without numbers in them is what I'm assessing tomorrow. Okay? And again, I don't mean that in a bad way. I just mean that in a like we need to focus and stay with me sort of way. Yeah? Okay. So we got the normal force. We got the applied force. Somebody mentioned a frictional force. Which way do you guys think the frictional force is going to go? To the left. Why? Yeah. So it's going to be moving this way, FAX, right? And friction always acts parallel to the surface, and it always opposes the motion, right? So that means that the frictional force is going to go in this direction. And I'm going to label that as the force of what on the box? The floor, yeah. The normal force and the frictional force always have the same object. Not always. Much of the time. Okay? They're both the same surface. All right. We're right up to tables 3 and 4 because I can see that number. What's another force acting or another given or something else I can add to my story?
There's the force of gravity.
Indeed, there is. Absolutely. There is a force of gravity. Which way does that one pull or push? Straight down towards the center of the earth, right? Straight down. So here we go. We're going to go ahead and draw that one in. And that's really the force of the earth on the box, FG. Okay. How are we doing? Okay? I hope so. Are there any other givens that we know? Or is that pretty much it? So I think we've pretty much got this left-hand side filled out. We need to use these things over here to solve the question, solve the problem. So let's start by writing out our F-net equations. F-net just means total force, right? Let's look at the x direction because we can do it. What forces are acting in the x direction? So what'd you say? The applied force, is it all of the applied force or just some of it? Just some of it. So we need to take that applied force and we need to break it down into two pieces. One of them goes in this direction. I'm going to call that FAX. We did this a little bit last trimester, but not a ton, so I just want to make sure you see it. And then you've got another piece that goes up this way. We'll call that one FAY. Right? So in the x direction, one of the forces acting is FAX. Are there any other forces that are acting in the x direction? What's that? It is, absolutely. The friction is also acting. Are they acting in the same direction or opposite directions? Opposite directions. We need to make sure that we're paying attention to that. So we might want to just write ourselves a little thing here. Which way do you want to be positive? You want to be right or left to be positive? Right generally seems to be a positive thing. So that means FAX is going to be positive, and the force of friction is going in the opposite direction, so it's going to be negative. You remember that there was a question that used to be up here in this box that said, is the box accelerating? And the answer to that is, no, it's not, which means that we could write this down as F equals mass times acceleration in the x direction, and holy cow, friends, that has to equal 0. If it's helpful to you when you're marking things on this, on your free body diagram, you can mark that these two things have to be the same, right? Because they add up to 0. I'm not going to look for that on a quiz or test, but sometimes it's just nice to have that so that we know that this is true. We doing okay so far? I'm going to come down here and do the F net Y, and then we'll start plugging numbers in, okay? Tell me what forces are acting in the Y direction. FG is, indeed it is. Is that one going in the positive or negative direction? It is, yeah. So we're going to make that negative. Anything else acting in the Y direction? FN. Is FN acting in the positive or negative direction? What'd you say? Positive, yes. And anything else, or is that it? FAY is also, isn't it? Yeah, which is weird, because usually we've just had like something like that, but no, we've got to add something else in there now. So we're going to say plus FAY. And then we ask ourselves, hey, is the box accelerating in the Y direction? No, it's not. There's a 0 acceleration. So MAY also is equal to 0. So far, how are we doing? Fantastic. Okay, so now this is the numbers part. This is the numbers part. We want to know FF and we want to know FN. FF lives up here. So we can use some things to figure out what FF is. We know that FAX and FF have to add up to 0. So we need to figure out what FAX is, don't we? Do we know what it is off the top of your head? No. But you do know how to use trig, right? Yes, we do. Yes, we do. So this is going to be FA times, ooh, what is that? Ooh, this is the adjacent or opposite side right here. That's adjacent. If you need that equation sheet out, get it out, my friends. You don't have to have it memorized. It's right there for you. I've got hypotenuse and I've got adjacent. Which trig function do I want? Cosine. Let me write this out for you just in case you're confused. The cosine of theta is equal to the adjacent over the hypotenuse. So the cosine of my angle is 30 degrees is equal to, the adjacent part is FAX, that's what I don't know, divided by my hypotenuse, which is FA, in this case is 250. So I can say that FAX is equal to 250 cosine 30. How we doing, team? Did I mess you up, or are you okay? If this comes naturally to you, you do not have to write out all of this stuff. Probably eventually by the end of this unit it will. If it doesn't and you need to write it out every time, 100% okay with me too. I don't really care as long as you can do it. So I'm going to write here, this is FA times the cosine of theta plus negative FF is equal to 0. Or if we plug things in, we can say that this is 250 times the cosine of 30 is going to be equal to FF. If you haven't done so already, go ahead and plug those numbers into your calculator. Or maybe you know what the cosine of 30 is. Maybe you do. And if you do, that's awesome. And if you don't, that's okay too. Plug it into your calculator. Make sure that you're in degrees, not radians. 250 cosine 30 will give us our value for FF. Did you get a number? Check with your table mates. Stay engaged with me. You can do this. All right. My back friends, back table there. What did you guys get, Max? 216.5. 216.5 what? You're like, that's a really good question. I don't know, because we've been doing all this crazy stuff. Look back into what it is. It's a force, which means it's got to be in newtons. You got this. All right. I almost said we're halfway done, but that's totally not true. We're halfway done with actually answering the questions. We're almost done with the problem. Can we figure out FG? Do you know how to calculate FG? Yes. Let's write it down. How do we do that? Oh, yeah, we do mass times the acceleration due to gravity. That's that 9.8. That's going to be a negative. Do we know the normal force? Or is that something we're really looking for? We're really looking for that. Do we know the applied force in the y direction? Can we find it? Looking for this side here. Which part of the triangle is this? Opposite, adjacent, hypotenuse. Those are your choices. Opposite. We know the hypotenuse. Opposite and hypotenuse is which of our trig functions? Sine. If you're not sure, get out your equation sheet. There is no judgment. Nobody will know, and it's totally okay. Opposite and opposite and hypotenuse is sine. So we're going to do the sine of theta is equal to opposite over hypotenuse. So that's the sine of 30 is equal to FAY over FA. So we can say that FAY is equal to FA sine 30. So this is FA sine theta, sine 30. And that has to add up to 0. Some of you are chomping at the bit, ready to go, 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 go. You know that the mass is 50. You know that this is 9.8. You know that this is 250, and you know that's 30. Go ahead and plug that in. You're going to move this one over and that one over, yeah, to solve for Fn. Go ahead and do it. If you're ready to do it, make it happen, friends. You got this. You got this. Once you've got an answer, check with your neighbors. See if they got the same thing you did. I did go ahead and write it out down here. So if you need to take a look at where my numbers are coming from, or if you have questions, you're like, what just happened there, Miss Kay? 100% fine to ask. You're doing okay?
All right, what do you get?
All right. Did you get an answer? And more importantly, does it agree with your partners? The one thing that's really kind of, I don't want to say tricky, but you have to pay attention to is the signs. So this purple stuff, the force of gravity, when we move it over to the other side is going to be positive. And the dark green stuff, when you move it over, is going to become negative, right? Because you subtract it. They have opposite signs, which, my physicist friends, should make sense. Because if we look carefully at the free body diagram, does it make sense that this purple one down needs to be equal to the green plus the green? Because that's all the stuff going up and all the stuff going down. And if you add up these guys, they need to add up to what? 0, because there's no acceleration. The net force in the y direction needs to be 0. So Fn and Fay have to add up to be Fg. Okay? That's where that all comes from. It's not just made up crazy stuff that Ms. Carbling just keeps saying. It came from here. All right. Did you guys get an answer? Or you don't want to share? You look like, I don't know. Give it a shot. Only one way to find out, right? 4,000. Hold on a second. Say it one more time. 4,676. What are the units? Newtons. Do you guys agree? I didn't do the math, so I don't know. Question mark, right? And I want to say thank you for throwing it out there, whether it's right or wrong. Again, I don't know what the answer is. Yeah.
I got 360.
365 newtons? 0.5. Okay. Let's double check and make sure that we're all on the same page. What's 50 times 9.8? 400 something. 400 what? 90-ish? Okay. And then we're going to subtract 250 sine 30, which is 125. So let's just double check. And again, we're all in a safe space working together. So I just want to make sure that everybody sees this. So 490 minus 125, I think is going to get you about 365. Did you figure out where your mistake happened? Oh, sweet. Okay, well, I'm glad you found it. That's right. And that's all good. Yeah, we're learning together. Okay, so I think that's going to give us our 365. Okay. Whew. Deep breath, my friends. That was a big problem. In and out. That was a tough one, but we can do it. We're going to do some more. What I need you to do right now is to send the person whose birthday is closest to today going forward. Okay? To get one of these for each person. Okay? Make that happen. All right, my physicists, you've had a little brain break. You've got a few more pieces of paper in front of you. I want to tell you what my plan is for the time from here until 10:27, which is only like a few minutes. I want to get us started on at least one of these problems, okay? So Mrs. Murphy put together a bunch of practice of the same kind of stuff. And if you can do these, you're going to be set. This is not necessarily homework. We're going to work on this again tomorrow. But today, before we leave, I really, really want to take a look at question number 4. Yes?
Are the answers going to be on Vince?
We will put, they're not up yet, but we will put them up. Yes. They probably won't be up tonight, but definitely by tomorrow they will be. Does that make sense? Yeah. So we're going to look at question number 4, and I'm choosing that one on purpose. The reason that I'm choosing that question is, if you notice, that it has to do with a ramp, right? And you remember what's happening tomorrow on your quiz is that there's going to be a ramp or a couple of ramp problems. So I figured this would be a good use of our few minutes together here, okay? So I gave you this new green sheet. You are not going to turn these green sheets into me. The reason that I gave you this new one is because you'll notice that it doesn't have the dotted lines, and that's kind of helpful for the ramp problems, okay? But you can use the old one. I don't really care. I'm going to use this one just because, again, it doesn't have the dotted lines, so that means we can make our ramp. So take a look at question number 4 from the yellow sheet that you've got. It says a 20-kilogram mass is allowed to accelerate down a frictionless 15-degree ramp. What is the acceleration of the block down the ramp? So the first thing that I'm going to do when I'm solving a ramp problem is to change the way that my axes go, okay? So instead of having them, horizontal and vertical, I'm going to go at a little bit of an angle. So this is the direction of my ramp, okay? And then my other axis is going to go just exactly perpendicular to that. Okay? That might be a little bit more than 15 degrees, but you get the idea. So this is my angle theta. Okay. How are we doing? Yeah.
I'm confused. So what is our quiz thing tomorrow about?
Your quiz tomorrow is assessing standards 3.1 and 3.2. I can relate balanced and unbalanced forces on an object motion, and I can draw and label a free body diagram. We've assessed these already. We did these at the end of try 2 or try 1 as well. The thing that's different this trimester that we introduced last week were the ramp problems. So the day that you were not doing the lab, you watched a video from Mrs. Murphy, and there were 4 examples that she did in class, or like on the video, and then there were 4 examples that she gave you to work on. All of that stuff is up on Canvas. So I would imagine, we have not written the check-in yet, but I would imagine it would look very similar to this. So if you're familiar with this, you should be good to go.
So they're all going to be ramps?
I don't know. I mean, there are probably going to be 2, and at least one of them will be a ramp.
Okay.
Is that fair?
Yeah.
Yeah, because I haven't written them yet, so I don't know for sure. You know what I mean?
Yeah.
Yes. But I guarantee there will be a ramp problem on there. Yes. That all known, we've got just a couple minutes. Let's do it, shall we? Okay. So here we go. Let's see. There it is. Okay. So this, if you want to just make a note of this on your scenario, that this is the yellow sheet number 4, so you can keep track of what's going on. A 20-kilogram mass is allowed to accelerate down a frictionless ramp. What is the acceleration of the block? So we really need to figure out, what we know. What forces are acting on this mass? The object is a mass. That's kind of nondescript, but it's there. What forces are acting on it? Force of gravity, the force of the Earth acting on it, right? Which way does that go? This is the most important part, friends. Straight down. And by that we mean not along this dotted line, but straight down towards the center of the Earth. So that one's going to go like this, straight down. This is the force of the Earth on the mass. We can mark that as FG. Are there any other forces acting on the mass? You can answer that question for yourself, because if this is the only force, where is that object going to go? Straight down. And is the object going straight down? No. Where is it going? It's going down the ramp. So there's got to be something else acting. Yeah. The ramp. Which way is the ramp pushing? What kind of force is it? Maybe that would be helpful. Is there friction? It's frictionless. Does the ramp act on the object any other way? Yeah. Normal. Which way does normal push, guys? Perpendicular. Don't turn your brains off yet, you guys. You need this. This is the force of the ramp on the object. Okay. Those are the 2 forces acting, no friction. If I want to write down my Fnet and Fy, or Fnet X and Fnet Y, really I like parallel and perpendicular? I want you here with me for just a second. I know the bell's going to ring in just a moment, but I need you with me here. Don't go anywhere unless if you know it, then go. But if you don't and you want to see it, stay for just a moment. Okay? FG is going to be broken into 2 pieces. One goes like this. This is FG perpendicular to the ramp. This is FG parallel to the ramp. This angle here is the same as this angle here. Okay? Make sure you know that in order to write your Fnet equations tomorrow. All right? We'll go through more of this problem tomorrow.
Is the check-in at the end of class?
I'm not sure. I don't know.
Yeah, do the end.
We'll see. I can't guarantee you, but I will take that into account when we make our plan. Sound fair? The trouble with the end is that then we have to say you have to be done by a certain time. Do you know what I'm saying? Which kind of stresses me out sometimes.
Wow.